Hello everyone, welcome to Kweku Online Study. Today I want us to talk about permutations and combinations, okay? So before we get started, I want to give credit to Alvin Academy, okay? I got this worksheet from Alvin Academy. Well, he has compiled past questions, okay, Cambridge past questions on permutation and combination. And I think this is really good past questions. So I'm going to solve it on my channel for the benefit of everyone, okay? So if anyone who works at Alvin Academy looks at this or watches this video, credit to you, okay? And I'll put the worksheet in the description down there so that you can also download it and then work with me. So if you haven't subscribed to the channel already, now is the time to do so. And if you appreciate this video, please give me a like. All right, so now I'm going to talk to you about the tricks that you need to answer permutation and combination questions, okay? So now let's start with the very first question. This is a paper that came back in 2014, May, June, paper 1-1 at maths. It says that how many even numbers less than 500 can be formed using the digit 1, 2, 3, 4, and 5, okay? Now, each digit can be used only one time. All right. Now, you want to get even numbers less than 500, right? Okay, so the first thing that you need to consider is that you could have only one digit, okay? So let's say one digit, we will have 2, okay? Even that's 2, or you have 4 for one digit. So this means there are two ways of doing that. It's either you go with 2 or you go with 4. How about if we have 2 digits? So for 2 digits, you have, I like to use the dashes approach. Okay, 2 digits, it means that it can end with 2. And if it's going to end with 2, then there's only one way to pick 2. Okay, but if it is going, if it ends with 2, that will make it even, right? Now, if we take 2 out of here, okay, let me circle 2. It means any of these remaining 4 could take this slot, okay? So there are 4 ways to fill the first slot. That makes 1 times 4 be equal to 4. Still, we are on the 2 digits. If it's ending with, say, 4, okay, of course, there is only, let me circle that 4 here. There's only one way to select that 4. And then the remaining numbers, any of those 4 numbers could fill the first slot. So that means that we have 4 ways of filling the first slot. Then 1 times 4 gives us 4 ways, right? Now, how about if there are 3 digits? 3 digits. I will go with 3 slots, okay? We want to get even. So if there are 3 digits and the first, it's ending with 2, so I'm going to circle 2, okay? Circle 2. All right, so there's only one way to get 2, but the number must be less than 500, so it can't start with 5. It means that 1, 3, and 4 are the numbers that can fill here. So there are 3 ways of going about that. Now, how many digits are there? Check it out. You have 5, right? You have selected 2, and then you have selected one of this 5. We are not touching it. You've selected one of these 3. We said any of them can fill this particular slot, right? Now, so that means out of the 5 observations, you've taken 2 numbers out, so you are left with 3. Now, any of those 3 can fill this last slot. So that means 3 times 3 giving you 9. All right, you are not done. There could be another slot for 3 where it ends with 4. There's only one way of getting a 4, okay? Now, any of these 3 would, if I circle 4, let me just circle 4 so we can do the analysis together. If I circle 4, we selected that already. We said it is less than 500, so this 5, we can't use it, okay? So we are left with 1, 2, 3. Any of these 3 will fill it. So now out of 5 observations, we picked 2. So it means any of the remaining 3 can fill the middle, giving you also 9, okay? Because you're going to multiply them out. Okay, so now to answer the question, what do you have? You have 2 plus 4 plus 4 plus 9 plus 9, and that is 28, right? Okay, because this is 2 plus 2 plus, this is 6, this is 10, okay, 19, 28. Okay, so there are 28 ways of going about this argument. So this is how you go about it. They want it less than 500. All right, that's cool. You do 1 digit, you do 2 digits, you do 3 digits, and you are done. Okay, right, let's look at the B. It says that a committee of 8 people is to be chosen from 7 men, 5 women. Find the number of different committees that could be selected. That's the keyword, selected. Now, when you see selected, you should know that the question is going to be about what? Combination. Okay, combination. Now, sometimes you not see selected, you see chosen. It's all about combination. Okay. All right. So we are going to apply combination. It will contain at least 3 men, at least 3 women. So this is what I like to do. M for men, 7 men. W for women, 5 women. It says it must contain at least 3 men. So we start with 3 men. How many people do we want? 8. So if there are 3 men, then there must be 5 women. If we have 4 men, then we have to get 4 women. If we go to 5 men, then the women must decrease to what? 3. You can't go to 6 men. That will give you 2 women. You understand? But we want at least what? 3 women. So this will make it invalid. That is wrong. All right. So that means that we end here, because you cannot even go to 7 men and go with 1 woman. That is basically wrong. So you just look at the constraints that they are telling you, and then you work with it accordingly. Okay. So let's get this guy here, push it some, maybe here, right, so that we can work with it. Now, this thing that you've done, the next thing you want to do is to do how many men are there. Take the first case. Okay, let me call it case number 1, case number 1, case number 2, case number 3. Okay, so for the first case, you have 7 men, you want to choose 3, and then you have 5 women, you want to choose 5. Okay, and then the second case, right, we can just put it on the calculator now. So we have 7 combination 3 times 5 combination, 7 combination 3 times 5 combination. Oh, why do I keep pressing the wrong things? Combination 3 times 5 combination 5, giving us 35. Okay, let's look at the next case. That is 7 men, you are choosing 4, and then 5 women, you are choosing 4. So what we have is 7 combination 4 times and 5 combination 4, giving us 175. Okay, and then finally we have 7 combination 5 times 5 combination 3. Okay, and then that will give us 7 combination 5 times 5 combination 3. Calculator says answer is 210. Okay, so at the end of the day, the number of ways, so number of ways is basically 35 plus 175 plus 210. So you have 35 plus 175 plus 210, giving me 420 ways. Okay, so this is the number of ways that you can form this committee if it's going to contain at least 3 men and at least 3 women. Okay, now this one is a little bit interesting. Take your time and then do it. It says that the oldest man or the oldest woman, but not both, this is the most important claim, but not both must be included in the committee. Okay, so these are the 2 situations that are going to, any of them can happen. It's possible that the oldest man is on the committee, so he's in. Okay, and then the oldest woman is out. Okay, or the other way around, the oldest woman is rather on the committee and the oldest man is out. Okay, so now this is how I want you to answer this particular question. You see, you want to select a committee of 8 people. So if the oldest man is in, all right, let me use black to differentiate it. If the oldest man is in, that is one way of getting him. You are done. And then your interest is on the other people. Okay, the other people. How many people are left? Well, there was a total of 12. So if the oldest man has been selected, then it means that we have 11 people to choose, right? But the eldest woman must not be on the committee. So the total people now reduces to what? 10. Okay, 10. But how many do you want to select? Well, you want to select 8, right? But the oldest man is already there. That means that now you want to select what? 7. Okay. So this means you have 10 combination, 7, giving you 120. Okay, then the next thing you want to do is to do the flip side. Of course, I will encourage you that you can just multiply by 2. Okay, but if you don't know that, then you can do the flip side too, where the oldest woman is rather on the committee. Okay, is there, and then the oldest man, that guy is so angry, so he left the committee. Okay, the oldest man is out. So it also means the same analysis. I mean, the oldest woman is there, so there's only one way, and then you have to. I mean, the oldest man also goes out. That means that out of the 12 people, 2 are gone, so you are left with 10 people that you want to select 7, not 8, because you have already selected a woman. So you are left with 7 more people to join the committee, right? So you do again 10 combinations. 7 calculator tells you that it's 120. Therefore, this particular question, you just do 120 plus 120, giving you 240. That is why earlier on I was saying that you can just multiply by what? 2. Okay, I mean, you do the 120, you just multiply by 2, because you know that it's either the man is in and the woman is out, or the woman is in and the man is out. So there are only 2 ways about that. So you can just multiply by 2, and then you are good to go. All right, so let's move on to the next question that we want to solve for today. So it says that how many different 5-digit numbers can be formed using 1, 2, 3, 4, 5, 6 different numbers here. Okay, if no number is going to be repeated. All right, now this one, there are 2 ways to solve this particular question. The first approach is that you can say there are 6 numbers that you want to. I'm going to use permutation. Why? Because I'm going to form something. If we're forming something, okay, you form it based on arrangements. You don't just pick numbers up and then you form something beautiful. The iPhones, the Samsungs that you see, they didn't come by chance. Someone took time to put the screen on another side, to put the volume buttons by the side, to give it a speaker, nice cameras. Yes, a human being took the time to form those things. So whenever you see the word formed, I mean, come think about permutation. Why? Because order is important. Nothing comes out of chance in this world. Well, I haven't seen some before. Therefore, this is 6 numbers that you want to arrange 5 from. Therefore, that is 6 permutation 5. And that will give you 6 permutation 5. Calculator says your answer is 720. Now, this is one way to go about it. You can also solve it this way. How many digits do you want to form? 5, right? So you have 5 slots. I like the slot system a lot. It also makes sense. So you have 1, 2, 3, 4, 5, right? Now you want to arrange these numbers. So any of the 6 can fill the first slot. Any of the 5, the remaining 5 can fill it. Now, any of the remaining 4 digits can fill this. Any of the remaining 3, any of the remaining 2 will fill that. So all that you got to do is to just multiply them out. Okay, that means that we have 6 times 5 times 4 times 3 times 2. That will also give you 720, right? So like I said, there are so many ways of solving this particular question. All right, how many of these digits are even? Okay, so you want to form 5 digits number system where it is what? Even, right? So if it is even, then it must end with an even number. So I like to use the number system with questions like these. The slot system. So I have 1, 2, 3, 4, 5, right? If it is even, it can end with what? 2. Okay, so if it ends with 2, then there's only one way of getting 2. All right, then the other 5 digits, any of them can fill the first slot. Any of the remaining 4 can fill the second slot. Any of the remaining 3 can fill the third slot. And then the remaining 2, any of them can also fill there. And then you just multiply. So you have 5 times 4. Okay, you just put the multiplication sign in between to show the examiner that you are multiplying them out. So you have 5 times 4 times 3 times 2 times 1, giving you 120. Okay, so this is first case. You can also argue that, well, this 5 slots that I have, there's another even number, which is what? 4. So if it ends with 4, then there's only one way to choose 4, right? Okay, so there are 6, you've chosen 1, so it's left with 5. Any of those 5 can fill this slot. Now you've chosen 2, so any of the remaining 4 can fill here. Any of the remaining 3, any of the remaining 2, right? Then you multiply them out, right? This will also give you 120. So you have done when it is ending with 2, when it is ending with 4. Now what you do is that they want even, so for even you just add them up. So 120 plus 120 giving you 240. Okay, now this is quite interesting. They say that how many of these numbers are less than what? 60,000 and even. So ask yourself, 60,000, how many digits? It's also 5. 1 2 3 4 5, right? So we have 5 digits. Check it out. 1 2 3 4 5. And then I'm also going to create another 5 digits. 1 2 3 4 5. I'm creating 2 because there are 2 even numbers in the distribution, 2 and then 4. Okay, so I'll start with when it ends with 2. There's only one way to do that. All right, in fact, let me write the argument here. 1 2 3 4 5. Oh no, there's no 3. It's actually 1 2 4 5 7 and 9. Okay, so if it ends with 2, that means that 2 is out. Okay, then you are left with 1 2 3 4 5. However, we said the number is less than 6,000, so the numbers that are variable to be used for the first slot must be 1, 4, and 5. If you use 7, then you are talking about 7,000. If you use 9, you are talking about 9,000. But we want something less than what? 60,000. Okay, so we just put any of those 3. That's 1, 4, 5. Any of those 3, we put that right here. Okay, so you have 6 digits, and then you have selected 2, all right, to fill this particular slot and this particular slot. So now any of the remaining 4 can fill this slot, any of the remaining 3, any of the remaining 2, all right, and then you multiply them out. We will multiply very soon, but you know what, hold on, let's go and do the same analysis for this one. If that even number should be 4, then there's only one way to select that 4. Okay, so back to this analysis. Remember, around 2 4 5 7 9. So if that number is 4, we are done. Only one way to get 4. Now any of these 3, all right, that's 1 2 5, can fill the first slot because it has to be less than 60,000. All right, so now out of 6, we've chosen 2, so we are left with 4 numbers, right? So any of the 4 can fill here, any of the remaining 3, any of the remaining 2, right? Then you multiply them out too, right? So it makes us see that it's the same thing for scenario 1 or scenario 2. Okay, so you can just do one scenario, multiply by 2. That is also encouraged. So we have 3 times 4 times 3 times 2 times 1, giving us 72. So this is also 72. Therefore our answer, all right, our answer is basically 72 times 70 times 2, right? Or can just add it, 72 to 72, you get 144 beautifully like that. And then you are done. Let me clean this here. All right, so this is how to go about this particular question. All right, now it says that how many different groups of 6, all right, groups of 6 children could be chosen from a class of 18 children if it has to contain one set of twins. All right, it has to contain one set of twins. Wait. I think I'm reading it wrongly. How many different groups of 6 children can be chosen from a class of 18 if the class contains at least one set of twins? Okay, there's that, it contains that set, one set of twins who must not be separated. Okay, now understand this, those twins must not be separated. All right. So that means that there shouldn't be a condition whereby the one of the twin is is in the group and the other one is not. I mean, the other twin is going to cry, right? Good. So we don't want to separate them. So this is what we do. Is either we put them on in the group or we put both of them out of the group. Okay. So that's how you should analyze it. You must not separate them. So don't put one on the group and one not on the group. It's either they are both on the group or they are both not there. All right. So let's deal with the case where all of them are with the group. Okay. So with the group, let's say with group. Okay. So that means that we have selected those two twins already. They are already selected. All right. And so the selection doesn't affect them. Okay. Like then the key word here is chosen. Okay. So you are dealing combination. Right, so we've taken those kids out already. That means that this 18 kids is now left with 16 because we've put the two people already on the group, right? So now we have 16 combination. Well, we wanted to have 6 children, right? But we have already taken 2, so that means we are left with 4. So that means 16 combination 4. That would give us 16 combination 4. That will give us 1820. All right. Now let's talk about the case where, those two kids are without the group. Okay, they are not there. We take both of them out. We don't want to separate them. So if we take both of them out, what happens is that let me see the argument. Good. So we do the first one is when they are both on the group, right? Okay. Now second one when they are not on the group. If they are not on the group, then that means that the selection that we are going to do, we must go with all the 18, okay? Because we are not going to separate them. And then we are going to choose 6 people, okay? So 18 combination 6, that will give us 18564. All right, so at the end of the day, we can just add them up, and then we see add to 1820, and that will give us 202384. Right. I hope I've done the analysis well. Well, this problem, I think I've not done the analysis well. I don't know, there's something not just right in my head. Okay. Anyways, I'm going to put asterisks here. All right, let's move on. So good. Let's look at this particular question. It says that you have 5 character password that is to be chosen from these 5 letters and then these 4 digits, right? Each letter has to be used once. Find the number of different password that could be chosen if there are no restrictions. Well, if there are no restrictions, how many characters do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 permutation. 5. Why am I going to use permutation? Well, it is a password. You don't just put anything on your phone and it unlocks. It must be in order. That means permutation, okay? So that's 9 permutation 5, giving us 15120. There's also another way to solve this particular question. You want 5 character, right? So 1, 2, 3, 4, 5. Now you have 9 digits, okay, or 5 characters, 5 alphabets, and then 4 digits. So you don't mind which one comes. So any of the 9 can fill here, any of the remaining 8, any of the 7, any of the 6, any of the 5. And I think when you multiply them out, you should also get the same thing. 9 times 8 times 7 times 6 times 5, giving us exactly, we got that. So you have more than one way to go about it. Okay, with this question still ringing in my head, I've made some wrong analysis. Just comment down there so that they will benefit everyone. Right. So it says that the password contains 2 letters followed by what? 3 digits. So we have 1, 2, 3, 4, 5 password. It must contain 2 letters. So any of those 5 could fill here, going from A to E. Any of them could fill here. Then now that we selected 1, it's left with 4. Any of those 4 will fill there. Then you go to this particular digits, which are 4. Now, any of those 4 could fill here. Now, I'm choosing 1 out, so it's left with 3. Any of those 3, and then any of those 2. Right, then you multiply them out. So what you do have is 5 times 4 times 4 times 3 times 2, giving you 480. Okay, so this is how to go about this particular question. But so when you ask a question like this, you can analyze it this way. Right, now we have a school has 3 concert tickets to give out random. Now when you see that it's going to be given out at random, that means that there's no order, there's no importance to whom it is given. They're just doing it by chance. Okay, so that means that it is a combination. Okay, you should be able to analyze a combination. All right, so they are going to do this to 18 and then 15 boys and girls. Okay, so that means that there are 33 people they are doing this to, so there are no restrictions. So out of those 33, they could give it to any of them. So it's combination. So 33 to combination 3, giving us 5, 4, 5, 6. Now 2 of the tickets are given to boys and 1 to girls. So that means 18 boys will give only 2, and then 15 girls will give only 1, and then that would be 18 combination 2 times 15 combination 1, giving us 2295. Cool, right? Yeah, let's continue. It says at least 1 boy gets a ticket. Okay, but how many boys are there? 18 boys and 15 girls, right? That's what they give us. Now, how many tickets are there? 3 tickets. All right, and they want to give these tickets, at least 1 boy will get the tickets. So that means that is either 1 boy gets the tickets, okay, and then 2 girls will get tickets, or 2 boys will get the ticket and 1 girl will get the ticket, or 3 boys will get the ticket and no girl will get a ticket. Okay, so now let's do the first case. If 1 boy is going to, that's 18 combination 1 times 15 combination 2, all means plus. Then we do the second case where out of the 18, 2 boys get it, and then out of the 15, 1 girl, plus out of the 18, 3 boys get it, and out of the 15 girls, no one gets it. All right, so we do 18 combination 1 times 15 combination 2. That will give us 1890 plus, and then we do 18 combination 2, 15 combination 1. That will give us 2295. And then we have 18 combination 3 times 15 combination 0, giving us 816. So in all, we do have 1890 plus 2295 plus 816, giving us 5001. Okay, so that is it for that particular question. Now, the next one says that find a number of different, how many different 4 digits can be formed using 1, 2, 3, 4, 5, 6. Okay, I mean, we've solved a question like this, right? So you can just say 6 permutation 4, all right? And then you can just go your way, all right? That'll give you 316. Or you can do the slot system, do 4 digits slots, so 1, 2, 3, 4, clean this one. Any of those 6, any of the remaining 5, any of the remaining 3, any of the remaining 4, you multiply them out, I believe you should get 360. 6 times 5 times 4 times 3, yeah, 360. I mean, any is fine. How many of the 4 digits numbers found in the, just what we did, is greater than what? 6,000. So you have 1, 2, 3, 4 slots, right? You want it to be greater than 6,000. If it is going to be greater than 6,000, then the first number to fill the slot is 6. Okay, so 6 must fill it, and there's only one way to fill the 6. Now, how many digits do we have now? We have 1, 2, 3, 4, 5. So any of the 5 could fill here. Any of the remaining 4, any of the remaining 3 could fill there. So you have 5 times 4 times 3, giving you 60. All right. Now, also, out of the 4 digit number found in greater than what? 6,000 but less than, and it's also odd. Okay, so let's get the numbers down. We have 1, 2, 3, 4, 5, 6. If it is going to be odd, you get your 4 slots. If it is odd, then it means that it can end with 1. So if it ends with 1, then note that there's only one way to choose 1. And it has to be greater than 6,000, so it has to also start with 6. And there's only one way to do that. Now we've chosen 2 numbers out, we are left with 4. Any of those 4 could fill here. Any of the remaining 3 could also fill here. So if we multiply them out, our answer is 12. Oh, why will I write 120? It's 12. Okay, how about, yeah, it is odd and it is ending with what? 3. Okay, well, 3 is also an odd number. So that means that you have 1, 2, 3, 4. It is ending with 3. There's only one way to choose 3. It has to begin with 6. There's only one way to do that, meaning that it's left with 4 numbers. Any of the 4, any of the 3 could fill these slots, giving you 12. 5 could also be the case, right? 5 is also odd. So if it is going to end with 5, then you have 1, 2, 3, 4 slot. That 5 is here. There's only one way to do that. It has to start with 6 because it's greater than 6,000. So there's only one way. Then those 4 remaining, or those 3 remaining, will fill the other 2 slots, giving us 12. All right. So it means that at the end of the day, our answer is just 12 times 3, right? Or 12 plus 12 plus 12. Giving us 36. Okay. Now, when I'm solving a question like this, I just do the first case and I multiply by the number of odds there. So I would have done the first one and multiply by 3. But since I'm teaching it, I want to teach it the way that you will understand before I tell you the shortcut. Okay. Now, the B, a quiz of 10 players, right? Chosen, telling you that you're going to work with combination, okay? Chosen from 8 boys, 12 girls, cool. Find the different, teams that could be chosen if the team have equal number of boys and girls. That means out of the 8 boys, we have to choose 4, okay? Oh, wait, 5, right? Because there are 10 players, so 5. And then out of the 12 girls, we have to choose 5, so that we do gender equality. We balance it on that particular quiz team. So we have 8 combination 5 times 12 combination 5, giving us 4, 4, 3, 5, 2. All right. Okay. So with the II part, it says that find the number of different teams that could be chosen. Okay. So if you are going to choose it, then that means that there's combination. And this team must include the youngest, the oldest boy, the youngest, and the oldest girl. So that means that 4 people must be on it. Okay. All right, must be on the committee. So these 4 people have actually been selected already. It's not part of the question. We are not going to select them. They're already there. All right. Okay. So that means that remember that we are selecting a team of how many people? 10, right? So if 4 people are there, then it means that we need to select 6 more people to go and join them. They make up the 10, right? Cool. Now, 2 boys have been selected, the youngest and the oldest. So that means that the boys are now 6, and the girls are also now 10. All right. Now, how do we select the rest? Well, they didn't tell us the number of boys or girls that we need to get over there, right? So that means that we are left with 16 people, okay? Out of the 20, we are left with 16. So that's 16 combination. How many people do we need to go and add to the 4? We need only 6. So 16 combination 6. The calculator will say that the answer is 8008. So that is the number of different teams that could be chosen. Okay. All right. So let's look at this question. maybe, and then this one, and then we call it a day. Okay. So it says that a committee of 4 is to be selected from 7 men, 5 women. Find a different could be selected. You see, selection. That's combination. No restriction. Okay. So you have 12 people in all, 7 plus 5, so 12 people in all, and we want to select how many people? 4. All right. So 12 combination 4. I have 4, 9, 5. All right. It says that there must be 2 male, 2 females over there. So that's 7 combination 2, and then 5 combination 2, giving me 7 combination 2 times 5 combination 2. 5 combination 2, giving me 210. Right. Cool. This is actually 210. Let me write it well. Okay. The next one, a brother, sister, Ken, Betty among the people. Okay, what is going on here? Find a different that 4 could be selected so that there are only 2 males and 2 female members. Now, which must include either Ken or Betty, but not both. Okay, both cannot be there. So we do when Ken is in and Betty is out. Okay, and then we also do when Betty, you can just multiply by 2 if you see it quicker, when Betty is in and Ken is out. Okay, so now let's see. Let's start with Ken in. Now, if we are going to select Ken, that means that now we have 3 people to select, all right, because Ken is already there. So the selection is going to be 3 people, okay? Now, out of these 3, it has to contain 2 girls and a boy, because Ken is a boy a boy is already on the committee. We add another boy, and then we add the 2 girls, okay? So since Ken is already on the committee, this 7 people reduces to 6. So that means you have 6 combination 1, and then Betty is out. So the girls will also reduce to 4. Betty is not even part of the selection anymore. Okay, so that means we have 4 combination 2, and that will give us 6 combination 1 times 4 combination 2, giving us 36. Now, how about if Betty is there and then Ken is out? Well, if Betty must be on the committee, then that means that there must be 3 selections that we need to do, okay? And out of this selection, Betty is already there, so we need 1 more female and 2 male, right? So since Betty has already been selected, it means that we are left with 4 females to choose 1 from. And now Ken is out, so that means that the men, instead of 7, reduces to 6, okay? And then we choose 2 from there. And we have 4 combination 1 times 6 combination 2, giving us 60. Okay, so at the end of the day, our answer would be 60 plus 36, giving us 96. All right, and then we are done. Okay, this should be our last question for the day. I am getting tired. It says Jen has 9 different flags. Right, the number of different ways in which we should find the number of different ways she can arrange, choose 3 flags from her 9. So choosing means combination. So 9 combination 3, okay, would be 9 combination 3 would be 84. Now Jen has 5 flag holes on a row. She puts one of her 9 flags on each flag pole. Calculate the different arrangement that she can make. Arrangement means permutation, okay? So out of the 9, she wants to arrange those 5 flags. So that's 9 permutation 5, giving us 15120. Or you can also put 5 poles there. Any of the 9 could be here, the remaining 8, the remaining 7, the remaining 6, the remaining 5. You multiply them out, I believe you get the same answer. 9 times 8 times 7 times 6 times 5. Yep, you get the same answer, 15120. All right, then next question says 6 digits of this particular number are arranged. So we have 7, 3, 8, 9, 2, 5. It's going to arrange so that we get a 6 digits. That's what even, right? We should find a way so that we can do that. Well, if it's going to be even, then it should either end with 8 or end with 2, right? So let's do our 6 slots. 1, 2, 3, 4, 5, 6. Okay, so if it ends with 2, there's only one way to get 2 from here. All right, then that means that if we choose 2, those 1, 2, 3, 4, 5 could fill here. Any of the 4 would fill, the remaining 3, the remaining 2, the remaining 1. So we put multiplication sign in between them. All right, so that means that we are going to get 5 times 4 times 3 times 2 times 1 times 1, giving us 120. You can also do when it is actually ending with 8. It's also even, right? And so you have how many slots? 1, 2, 3, 4, 5, 6. So you have 1, 2, 3, 4, 5, 6. Cool. So if it ends with 8, okay, there's only one way to select 8. Those remaining 5 will fill here. The remaining 4, the remaining 3, the remaining 2, the remaining 1 will fill there. That will also give you 120. So your answer is basically 120 times 2, giving you 240 different ways that you can rearrange this to get even. All right, and then you are done. So this is where I want us to end. There are other questions down there that follows the same pattern. Cambridge is not going to change. I believe by now solving this question has helped you to even see that, permutation combination isn't really difficult. It's just analyzing the story and you should be fine. All right, so this is where I end. These questions are there for you to solve. The references are also there. A big thank you to Alvin Academy for putting this worksheet together. All right, you should check their website. It's really cool. Okay, get a lot of worksheets over there. All right, so until we meet again, we're in the COVID time, so please take care of yourself. See you at another time. Bye for now.